Welcome everyone to an Access Academy by APH. This is Code Jumper 101B. Hopefully you are here for Code Jumper 101A. If you weren't and you feel this is a little too much for you, go back and watch A and join us for another B. If you are also here for ACV REP credit, your opening code word is custom, C-U-S-T-O-M. And I am going to open the poll, letting us know what is your job title, and you can pick more than one, where you are from, and then how you heard about this webinar. Again, welcome to an APH Access Academy Code Jumper 101B. We are so glad to have you with us today. If you want, you can drop into the chat who you are and where you're from. We'd love to say hi. If you are also collecting ACV REP credit, your opening code word is custom, C-U-S-T-O-M. And there is a poll to tell us what is your job title and where you are from, and then how you heard about this webinar. Welcome to the APH Access Academy Code Jumper 101B. We are so glad to have you with us today. There is also a poll to tell us who you are and where you're from. And if you are collecting ACV REP credit, your opening code word is custom, C-U-S-T-O-M. Your opening code word is custom. If you can, Susie, can you write your question in the chat? You have your hand raised, and I'm not sure if you did that on purpose or on accident. And also inside the system, you should see a poll asking what your job title is and where you are from. I am going to end that poll so that we can get going, and let me share those results with you. We have 43% say they are teachers or students with visual impairments, 29% orientation mobility instructor. We have a chunk of other, and we have a couple of technology or coding or program teachers. Welcome, welcome. We are glad to have you with us. Where you are from, actually 29% is Midwest US, but we have a couple people from Canada and somewhere from another country, we think. And how you heard about this webinar, a majority of people from the email at APH, though 21% are from the APH website. Welcome, welcome. I'm going to stop sharing. I'm going to say one more time that the opening code word today is custom, C-U-S-T-O-M, and I am going to turn it over to Paul. Paul, it is all yours.
All right, thank you, Leanne. Welcome to this 101B. So we're really going to get deeper into the weeds, so to speak, today in Code Jumper. Hopefully you got a chance to be part of the first one, and we'll just expand on that today. Our time today, of course, will include our intros and objectives as we're going through right now. We'll overview 10 advanced lessons in Code Jumper. We'll add custom sounds. That sounds like the most fun part to me. Next steps in computer science. As with all the other sessions, they've been very interactive. So please make sure that you put your questions in the chat. 1.5 hours ACV REP credit. And of course, we do have closed captioning. So glad to be able to let you know that. Code Jumper, just in case you need a refresher. If you make a purchase non-quota, it's $999. The quota price is $769. The quota catalog number, the APH catalog number, is there as well. So that's always a really good way to search for it on the website. And so let's take a look now at our presenters. They will be familiar to you. Beth Dudycha, Senior Manager, Content Development for I2E. And Robin Lowell, Senior Manager, Accessibility for I2E. And we have 3 objectives today. Kind of covered them a little bit already. Let's go back over them again one more time in more detail. So we're going to engage in 10 advanced lessons for Code Jumper. We're going to learn how to add custom sounds to the Code Jumper app. I vote for sports sounds. Participants will discuss how Code Jumper prepares all students for the next steps in computer science. So With that in mind, there's a lot to do. So let's turn it over to Robin and Beth.
Great. Thank you, Paul. All right, so I'm gonna go ahead and share my screen. Let's see here. There we go. Screen 2. Oh, and share. Make sure I click all the right buttons in all the order. All right. Okay. Great. So welcome everybody. And if you had joined us for the first session, welcome back. Excited for everybody to be here. Again, my name is Robin Lowell, and I am the Senior Manager for Accessibility for I2E. And I have been a teacher of students with visual impairments for 15 years. I've worked in many different settings, from itinerant to residential to distance learning. I was the high school math teacher at the Washington State School for the Blind, where I taught distance math. I was at a distance, my students were at a distance, and we also had kids in the classroom. So I am well versed in what distance learning looks like, which many of us are doing right now. And I have had the privilege to, along with Beth, to be working on the CodeJumper curriculum and for the past year, and really getting that dialed in and creating some great resources to use CodeJumper in the classroom, in groups, and independently. So I'm really excited to share more with you all today about the second part of CodeJumper, those more advanced lessons, and what that kind of looks like. So with that, I'm going to turn over to Beth, and she's going to tell us a little bit of herself.
Thanks, Robin. Hi, I'm Beth Dudycha, and I'm super excited to be here today. I love CodeJumper, and I'm excited to share some of the more advanced things that we can do with it. I was an elementary teacher for quite a few years, and then I became a programmer working for a startup company in a curriculum design, and now I'm working at I2E doing a lot of content development. Very passionate about everybody understanding a lot about computer science from preschool, kindergarten, all the way up. Everybody needs to know some things about computer science, no matter what field you are going to go into. And so it's very important that we make sure that this is accessible to all of our students across the board. So with that, why is CodeJumper so important? Well, it's kind of just answered some of that, but Robin, did you want to expand on that?
Absolutely. So why is CodeJumper so important? And I think the more time that Beth and I spend with CodeJumper and with accessible coding and thinking about coding for all of our students, we realize that CodeJumper is such a jumping off point for a lot of our students. So like I said in session 101A, and I just really want to reiterate, is that there are some really fantastic coding programs out there for our younger kids, but unfortunately most of them are not accessible. They're very visual, and everything is block based, meaning you drag and drop and you can use your mouse, and you can't really access and really be fully able to participate if you can't see what's going on the screen. So you really can be part of that process of the planning and what could happen, but you don't actually get to engage in the end product. So that's where CodeJumper really steps up and gives our students, all students, a chance to really have this hands-on, tactile, auditory, visual experience using all of those senses to learn about coding. And CodeJumper too, and having gone through all those first sessions and what we're working on now and all these different ideas, it's that the more opportunities, the more sensory opportunities with coding, the better. So they can really start to apply it to all different parts of their life. And today, we will be talking about some of those more advanced concepts. And it's really kind of that bridge and those stepping stones to what comes next after CodeJumper and the text-based coding. So thinking about why is it so important from the very beginning, from lesson 1 all the way through lesson 11, 13. I'm blanking on how many, and I know off the top of my head I could name them all. To the very last lesson, we're building on this idea of, yes, I can code. Yes, I can do it. And the more I was thinking about just this morning, thinking about
more opportunities we give our students for we can say, yes, you can, and then they can go, oh, yes, I can, the greater opportunity and more, the wider opportunities of things that they believe that they can do. So coding is really that jumping off place where that either could become a differentiator of, no, I can't do that, and taking a different path than their peers, or saying, oh no, yes, I can. And so what other opportunities are there out there for me? So that's one of the many reasons. I think Beth and I could spend 4 hours just talking about why CodeJumper is so important, but we'll leave it at that for right now. So the curriculum, we went over a little bit about this before of what the curriculum looks like. So we have our primary lessons, and then we have our advanced lessons. So Beth, I'm going to actually this time pull up the CodeJumper website. And if you want to kind of talk us through what those advanced lessons look like. So first I opened up CodeJumper website, and then there's a tab for resources. So I'm going to click the resources tab, and this is where you can find all that great information. There's the Microsoft Educator Community Course, the user guide, lessons, and we're going to stop right there and open this up and look at what our lessons, what we have for our advanced lessons.
Yeah, so the primary lessons, which we covered some of in the last session, were computer systems, sequence and algorithm, parameters, threads, debugging, loops, sequences, and decomposition. And all of those elements are reused and reused and reiterated and built upon in the advanced lessons. So it's we definitely do not just ignore debugging. Debugging is something that happens all throughout the computer science curriculum. So today we're going to kind of cover a few of these lessons: constants, selection and conditionals, selection and random, variables, counters, nested loops, networks, topologies, protocols, binary numbers, and Boolean logic. And we're not going to get to all of those today. That would be just way too much to cover in one session. But we're hoping to give you just enough to whet your appetite and feel like you've got enough groundwork, if you know nothing about computer science, that you will leave here with a little bit of understanding. You may not feel super confident that you know or could pass some kind of quiz on it, but you might feel confident enough to give it a try with your students. And part of this learning, especially if these words are all new for you, it does take a little bit of time to just practice with it and keep understanding these concepts. So we're going to go over a few of them today. And we would love for those of you who have a kit to follow along with us, and we'll get to that in just a minute. And be sure to ask questions. We are here to answer your questions. We would love this to be as back and forth as we can make it. I know a lot of you do not have a kit, and so by looking at these lessons, when you see this list, feel free to kind of peruse through it. It's available in PDF or HTML formats, and ask us some questions if you have them, because we're super happy to jump off and make sure you feel confident about what these concepts are and how they work with CodeJumper. Sorry, go ahead.
Before we move on to assessments or anything, let's talk a little bit about these last lessons now that we're in the advanced section. So maybe I'll open up, which one do we want to look at? Let's look at network. Actually, yes, we're going to look at networks. And so
these are pretty abstract.
Yes.
Right, Robin? Like, they're not as tangible concepts. They're definitely concepts that younger kids may have difficulty grasping until they can really understand some more abstract concepts. Which one did you click on? I missed it.
I opened up the networks.
Oh, yeah.
So looking at these are a little bit different. So with CodeJumper, there's not really a way to really discuss or to create a program that shows networks on CodeJumper. But it's so important that this be part of the curriculum. So this is at the very end. This is very advanced for the CodeJumper program. But So we're not actually using CodeJumper with this, but these concepts are critical to be able to move on to those next steps in computer science education, such as going to text-based coding. So for the introductory lesson, we actually, for this one, so if you remember how we had the lesson set up, we have a hands-on unplugged version, we have a guided lesson, and then we have an extension. And so these ones are different, where we have an introductory lesson activity and then a lesson extension. So we're doing things, basically a lot of hands-on unplugged activities. For example, for networks, that's just looking at a network is a group of computers or electronic devices connected together by cables or Wi-Fi. So you connect to your network to connect to the internet, and or if you have more computers in your home or at school, all those computers are connected to a network. So in this first lesson, we're showing the students how that network works. And so for this example, this is for, for the classroom, you use string or yarn, and then you have tape, and then you use index cards, we have envelopes and paper clips. And what we do with this is basically create a string network. And so we have an envelope, or you have a card where you want to send a message from one computer to a next. You write it on the card, you braille it on the card, put it in the envelope, attach it to the string, and send it down physically to the next person. So that we're seeing this network actually in action in a paper and string format. So to kind of get that idea of how that works. So there's all the what you need there to create this network experience from a hands-on unplugged version of this. Beth, you want to add anything to that?
No, just that these experiences, although we have them set up right now to be in a small group, could be totally modified to be done remotely. Obviously, it's more fun if there's other people involved, but you could probably transition this pretty easily to do remotely as well. But the main concept is to take something abstract. Understanding how data actually travels through a network is very important. And it sounds very simple. Oh, I connected my phone to Wi-Fi. But it's actually much more complicated than that. We want students to understand some of the intricacies. And in order to do that, we need to make sure they understand the basics. And so in this lesson, we give them a really tangible way to start, and then we add some complicating factors to try to help build their understanding of how big networks work and how topologies work, and making sure that if they choose to go into this field, they've got enough understanding of what these things are, because they might have that solid memory of working with string. And though it may seem simple, the concepts are pretty, can be abstract depending on the age group of your students. But some of the earlier advanced lessons are still using CodeJumper, and I think that's where we're headed next.
Yes, and
right?
Just in this talking, the way I came up, like, how do we modify this for remote learning? What popped into my head is, if you have a group of students who are working on this, is you actually physically write a letter and send it in the mail with an instruction. And, getting mail is really fun. So you write a letter and put it in the mailbox, and then it gets sent, and then the receiver gets it, does whatever it says on that card, and then they send it on again, kind of like a chain letter. But that would be really fun to have an opportunity to connect with other students in a totally different way than you typically would. So that's kind of fun.
That would be fun. And it's kind of eye-opening also. A lot of our students grew up with technology, and they have some misconceptions that when you open your phone, everything's right there. And it just shows up on that little tiny screen, and it's just magical. And it's there are some misconceptions that students have about how things get to be in the places where we want them to be. And so these are some fun units, because it's a little more eye-opening for them to understand how it actually works. So that's a fun one. The other stuff that's on here, Robin, is we can go back to lesson structure in a little bit, but the assessments are on here on this page.
Yes.
Sorry, if you go back one.
Yes, and then I'll go
on the website.
the website.
In case you were not with us on the first series, that's fine. There, each lesson is structured in a way that, as Robin sort of already talked about this, but that there's an unplugged, a guided, an exploration activity, and then there's a check for understanding at the end of each lesson. But at the end of each unit, there are some larger assessments. And right now, Robin has the webpage up, and there's a primary lesson assessments, which is available also PDF and HTML. And there's a project rubric with that. And then there's also one for the end of the advanced lessons. So it is sort of a project where you would observe and see how much of the information that was given, or how much of this knowledge base are students able to practice and explore on their own in a way that's the appropriate way you want them to explore it. And so there's a couple of rubrics, or there's a rubric in there that will really guide you if you wanted to let your students at the end of the advanced kind of check out, are they getting what we taught them? Is this making sense to them? Are they ready to move on to something like text-based coding, or move beyond? The areas in the rubric that are covered are project planning, program creation. This one has a peer review, because these are probably students that are ready to and capable of reading what somebody else has written, or following their program to see if there are bugs or errors, or to see if it makes sense for what they want to have as their outcome. And presentation. So students will be presenting their learning and demonstrate what they've learned in a presentation mode. So it's a little bit different than the primary, because it's probably a different age group that can handle that a little bit easier than the primary kids.
Right. And then I just opened up the web page with the rubric on there. And again, it has all the criteria like Beth said, and then you can go through and make sure all the pieces are there, and easily assess what your students are have done on the project. And there's also for this one, there is internets. Come on, internets. My PDF is not working. But there's also there's advanced computer science journal pages. So that way it's nice, because those, like how to set up like the
template pages.
Thank you. That's the word I was looking for. In here with all the different pieces, and there's check boxes, and it's all accessible, and you can use it with a screen reader very easily. And make sure you have all the pieces of your project already put together and ready to go.
And that actually is something that teachers might consider using as part of their computer science journal. They might borrow pieces of this throughout the computer science journal, throughout all of the lessons in the advanced section, because there is more of an ability to let students show what they know. And they know so many more pieces. They know more concepts, and they can embed different elements into their programs. That something like this, you could modify your template for your computer science journal and utilize something like this. Then, of course, when the assessment comes along, they'll be real familiar with it, but gives kids sort of a layout for, this is my project, this is the title, this is what I'm going to use in it, this is how it's going to be laid out. That pre-planning is significant, so that when they get the point of putting it together in CodeJumper, they've already thought about it. They've done the thinking part behind, and they're not just playing on CodeJumper. They're actually trying to mimic what they had created in their head ahead of time. So, all right. Let's see. So we kind of went through that. I think we're ready for pieces and parts.
I think so. Okay, pieces and parts. Let's just review. Since it's been a week, maybe more, for a few weeks, actually at least a few weeks since we've gone through this session. So let's review the pieces and parts. So I am going to change my camera view, and so I have, there we go. So up on my screen now, on the right-hand side, I have my document camera showing all the pieces I'll be going through. And on the left side, I have the app. So as a quick review, the largest piece is the hub. And to orient it, you have the flat side away from you and the side with the ports on the front towards your body. And we have the large button inscribed with a play button, and then a smaller circle inscribed with a square for the stop button and the rocker switch to turn it on. We have the mouse-shaped command pods, the white and blue, with 2 dials, one flat and one tall is our play pod. We have, we're going to actually be introducing some new things. So those are what we're going to go over. And if we remember, we have the loop pod, which has 2 cords coming out, 1 dial on top, and 2 ports that are exiting the pod opposite the short cord. So that's the loop pod, just in review. And then, so the ones I want to introduce to you today are, we very briefly just looked at the all of the plugs. So the plugs are a couple of inches long and they're purple. And on the top, they have raised dots that mimic dice. So we have 1 through 8. So the plug for number 1 has 1 dot, plug for number 2 has 2, and so on all the way up to 8. We have, ooh, I have it upside down. We also have 4 other plugs. We have one with a print R on it, and that is for random. It's raised, so you can see the R on it. We have one with a raised infinity sign, the print infinity sign. We have a plus sign for counting up. We have a minus sign for counting down. And then we have 3 other plugs that are the same that Beth's going to be introducing us to later. And these are called the variables. These are a little bit longer, maybe 2.5 inches, and they're gray colored. And on the top, they actually have a port. And so we'll be looking at those. And here's my little hack. So when you have your kit, they come in a little square or in a plastic bag. And I actually took a piece of styrofoam. It's about 2 inches by 10 inches long, and it's about 1 inch thick. And I poked all of the plugs upright into it so I can easily find my plugs instead of having them scattered on the table. And that's my little hack that I've created to easily keep my plugs organized. When I put them away, I just put them back into the kit as normal and store my styrofoam elsewhere. So that's an easy way to just create a good stand for all of your plugs. So that way, and you can easily see them, find them, and right now it's a great way to display them so we can all see them. So those are the plugs. I'm gonna move those out of the way for just a moment. And then we also have the selection pod. So this one's a little bit different. It has the same basic shape as the rest of the pods. So it's computer mouse shaped. But on the top, we actually have 2 dials that have spokes on them. So we have a 2-spoke dial, and we have a second one that has 3 spokes on it. And this is the selection pod. This is our if-else statement, and we'll be using this in a little bit. And below each of the dials is a port that we can plug other command pods into. So there's 2 of those, one for the 2-spoke dial and one for the 3-spoke dial. And on the side directly opposite of the ports is the short cord that we see on all of our other pods coming out of that as well. And that's the selection. So that actually will split our program. And so we have to have a way to bring it back together. And so then we have the merge pod. So I always think of the merge pod and the selection pod as a pair that always go together, because we can, and we'll go into deeper detail when we actually build our program. But the merge pod brings that program back together. So this pod, again, is computer mouse shaped, but this one has no dials on it at all. And then one of the longer sides has 2 short cords coming out of it. And then the opposite side is a port that comes out. And both the merge pod and the selection pod are green and white in color. So those are the plugs, the pods that we'll be using today, along with the play pod and the loop pod and possibly a pause pod if we have enough time. So that's the ones that we'll be using. So I think now we're actually ready to dive in and look at what we're going to be doing. But before we do that, I would like to make sure if you have a kit, to make sure that it is connected to your computer via Bluetooth. So if you have a kit and it is connected, can you please put a Y in the chat box so I know you're ready to go? If you have a kit and you cannot get it connected, please put an H in the chat and I will help you out to see what we can do. Beth and I can help you out to make sure you get connected. So I'm just going to give everybody about a minute or so to make sure their hubs are on, connected to their the Bluetooth on their app, and we can go from there. So far, I have 2 Ys. I'll just give you guys a minute just to make sure that you're all ready to go.
And which pieces will they need to, Robin? They need their plug.
Right now, yeah, we'll get into that, and just let's start with just making sure that the hub is connected. Okay, so I only see 2. Do we have more kits than just Erin and Christine? Yes, okay, Tony, great. Ready to go? And if you have a kit and we're going along and you're not able to connect, please let us know. And then we can pause for a moment and make sure that you have what you need. All right. Okay, I think we'll kind of move forward a little bit. I'm going to clean up my desk, make sure I have enough space for what I'm going to be creating now. So the lesson we're going to be starting with is lesson 9. Bring my PowerPoint back up. Pieces and parts. Okay, so we're going to be learning about constants. So a constant is a value, is a fixed value that cannot be changed. And we all learn about this in math, our constants. We have 1, 2, 3, all of our numbers are constants. And then when you get older, we're not doing negatives, but those are constants as well. So we have, at our disposal in CodeJumper, we have 8 constants. And those are those plugs that we talked about before. So on the screen right now, we have a picture of all 8 plugs. And our lesson objective is after this lesson, students will be able to develop programs that use constants. So these are our plugs. So if you have a kit, make sure that all of your plugs are available to you. And right now for this lesson, we're just going to be using the numbers 1 through 8. Just have the numbers available and we don't have to worry about the random or the counters. Okay, so remember, a constant is a fixed value that cannot be changed. And this is an important concept. So the materials we're going to be using is, if we were writing this down, we'd use our computer science journal. So you can take notes for yourself if you'd like. We have 4 different constant code cards for this lesson. We're not going to be using them all today. And then we also can do a sound set mapping. So what I would like to make sure everybody has out is 4 play pods and your constants, obviously your hub attached, and a loop pod. We may or may not have time to do the loop, but we'll see how far we can get. Okay, so the first thing I want to talk about in this lesson is looking at the play pods and the constants and like, what is the point of that? So we have this where we can do sound set mapping. So we sent 2 PowerPoints. One are just the code cards. So if you would like to look at the code card, this is the lesson 9 constant sound set mapping. It should be the first slide in that second PowerPoint. So what we're going to do is figure out, this is basically finding out the mystery animals. So we have to put together a program. And in this program, I'd like everybody to take 3 play pods and create a program. So we're going to take a program, we're going to take the first play pod, plug it into port thread 1, which is the very far left port on the hub. Okay, I'm going to change my screen back to so now what I have as my visual is the document camera showing the showing Code Jumper. So we have the hub on the desk, and plugged in we have one play pod. So again, thread 1, plug in one play pod. And to that first play pod, plug in a second play pod. So we're using the same thread. So now we have 2 play pods plugged in. And I'm going to actually plug in one more. So we have a program where we have 3 play pods connected. And we know that our sound set is supposed to be animals. So I'm going to see if my computer will cooperate. Yes, it will. There we go. There we go. So what I have on the screen now, again, is still the document camera showing the program. On the left, I have the Code Jumper app open. And then below that, I'm actually looking at the PowerPoint with the tables that we're going to be putting in our information. So our table looks like this. The header row says trial 1, and then in the second column is play pod, third column is constant, and the fourth column is sound. And that first column is just giving us our information. So we're going to use the sound set for animals. So under the play pod column, so play pod 1, it says put in constant 4. Okay, so I'm going to pull my constants and pull plug number 4. But I think I have an error because I'm looking at my app and it says I have a little debugging to do because it says my my sound set is twinkle twinkle and I need to have sound set animals. So I'm going to tap on that, and then I'm going to change my sound set to animals. Okay, so now I have animals. So we need to figure out, the goal of this is I put in constant 4, and we need to figure out what sound that's going to make. So I'm going to take this constant number 4 that I have right here, and I'm going to insert it into the sound dial on my play pod. So there's a little port on top. I'm just going to click it in. All right. And so if you remember that when we're inserting a pod or putting in a plug, that you know it's connected when you hear the connection sound on the app. So I know that is correct. Okay, so that's the first pod. And then it's telling me in the second row for play pod 2, put in constant number 7. So I'm going to pull constant number 7 out of my little stand. And again, finding play pod, I'm going to just trace the code. So I go from my hub, play pod 1, touching play pod 1, touching play pod 2. And in the sound dial, the short donut shaped one, inserting the plug number 7 into that one. Okay, and now our table is telling us for play pod 3, put in constant number 2. So I'm gonna trace it over 1, first play pod, second play pod, third play pod. So my hand is touching the third play pod, and it's telling me I need to put in constant number 2. All right, so they're all connected. And this is an important one that if your students are visual, that they're not looking at the app. We want to be looking at just at the Code Jumper kit. So when we play our program, we have to figure out, what sound is in for each constant. So constant number 4 is our first one, and so we know it's going to be animal sound, and we don't know what it is. So let's play our program and see what we get. I'm actually going to turn the speed. Okay. Sheep, dog, and pig. I'm going to change the speed because that's much more pleasant. Well, the pig, I'm not sure about pleasant, but so I'm going to press it again so I can write down my information. So we have sheep, Dog. Okay, so then I have this table so I can fill it out. And so the fourth column says the sound. So the first one I know was sheep. And then I can put in that my second one was a dog. And then the third one was the pig. Okay, so we have a second table that's exactly the same, but this time the sounds are in a different order. So now we can say, okay, we understand that this constant, the value of this constant number 4 is a sheep. So we can make an educated guess. Our hypothesis would be that now the sound order will be pig, sheep, dog. So we're going, okay, what happens when we change the order? We're going to get a different program, and our story can be different. In this case, it's animal sounds. So I'm just going to quickly change that. And so the first, I pulled out the plugs out of all of them. And then I'm going to put in constant 2 into the first sound. And then I'm going to put, because it's telling me 2, and then I'm going to put 4 into the second play pod. And now I'm going to put the number 7 into the third play pod. Okay, now we'll just play it again. See if I was correct where I said pig, sheep, dog. So yes, my hypothesis was correct, and so then I can put that information into my table in my computer science journal. So one thing's interesting is when you put a constant in there, remember it's a fixed value. So when we turn our sound dials, it changes it to the next sound. But if a constant is plugged in there, wrong one. That no matter what you no matter how many times you turn that dial, it's always going to stay on the sound that, for this example, it's pig, because it's that constant, that plug overrides the turning of the dial, which is really great if you're creating a program. Then sometimes you can actually knock the dial. Then by putting in a plug, then you don't have that that worry of accidentally turning the knob to something different. So that's really that very first introduction to what the constants are. And so they can go into the loop pod to tell you how many times your loop to go around. They can go into the sound dial to, again, put the, choose the exact sound that you want. And then they can go into the selection pod as well, which we'll look at in a little bit. So that's the first little lesson we have around constants. And so let's look at what's next. What's interesting. So there is an opportunity to create, a song, a program. For example, the song "Make New Friends" with constants. And this one is interesting because you can create your program. So if you're not exactly sure how the song goes, then you can figure it out using constants. When I first had CodeJumper and I was trying to figure it out, and a computer engineer friend of mine I was trying to figure out how to build Beethoven's Fifth Symphony, and that is a complicated program, and I could not figure out the order exactly. So he's like, use constants. So we made all the program, we put all the pods together, and then we use the constants to figure out the correct order. So it's a good problem-solving tool as well. So I'm going to build this program of Make New Friends. And I have my constants, and looking at our code card. So on the screen we have our code card, and I'm not going to actually put it in the loop right now just for time's sake, but we have a play pod and then a constant. Play pod, constant, play pod and a constant. And so I'm going to put those in. And if we have 4 play pods, the lion. If you're following along, use the same program that we already have. So we had 3 play pods connected. I'm going to change my screen a little bit so we can see all of this, what's going on. And we have that. And then I'm going to go to the next slide. We now have 4 play pods in our program. So make it work the best on the screen. Okay, there we go. So I have the hub and then 3 play pods attached to each other to form one program. Okay, so it's telling us to put in the constant. So we'll put in constant 1 in our first play pod, constant 1, click. Okay, oh, but first, again, one thing I always forget to do first is change the sound set. So I'm clicking on the thread 1, and then I'm going to go to make new friends. Okay, there we go. Okay, so the way it's set up right now in the app, it's out of order. It's each play pod. I'm gonna go ahead and play it right now before I get going. So I'm gonna play it.
A circle is round, it has no end. That's how long I want to be your friend. Make new friends, but keep the old. Make new friends, but keep the old.
So that's not in the right order. So using constants, we can actually create our program, putting in each constant so it has the right sound set, because we know it's a correspondence. And we'll learn about that more when Beth goes over the custom sound sets of how those actually look. So I'm going to actually turn.
Make new friends. A circle is round. That's how long I make new friends.
So I changed the speed to 1.5 in the, to make sure we don't run out of time. So I'm going to insert the first play pod plug into play pod 1. So that's constant 1, click. Okay. And then I'm going to insert constant number 2 into the second play pod. All right. And then plug 3, constant 3 into the third, and then into the fourth one. Okay, so now I'm going to press play and see if my program makes a little bit more sense.
Make new friends, but keep the old. One is silver and the other's gold. A circle is round, it has no end. That's how long I want to be your friend.
Okay, that makes a lot more sense. So now we can actually learn that song. We created this program using constants 1 through 4. And you can put it into a loop and use a constant to tell us how many times you want it to go around and around and around. So, which is pretty fantastic. All right, so that's a very brief introduction into constants. I would like to pause for a moment. Does anybody have any questions? And for those of you who have a kit, were you able to create the Make New Friends program?
We have Susie Rich who's raised her hand.
All right.
Let's see. Okay, Susie, I've turned on your mic.
Can you hear me?
Yes.
When you did the animal sounds and you had to change the order, that wasn't a constant, was it? Like when you did pig, sheep, dog, that's a new constant, is it? Like a constant can't be changed. So did you rechange the order to make it a constant again? Is that right?
I took out the plugs and I changed the order of them, if that's what you're asking. So yes, I took the plugs out and I inserted it into a different pod to change the order, because it was first 4, 7, 2, and then I changed the order to be 2, 7, 4 by physically pulling the plugs out and putting them into a different pod.
Okay, thank you.
You're welcome.
The connection is unstable.
All right. Okay, so those are the very basics of constants. They do just what they say. They make that sound constant throughout. Okay, so let's go on to our next kind of topic that we're talking about. So that was lesson 9. So we've talked a little bit about selection and random. So again, make sure that you have out your selection pods, which is the 2 dials on top, one with 3 spokes, one with 2 spokes, and the merge pod as well. I'm going to move these out of the way. So in this lesson, students are going to learn about what selection and conditional statements are. So an if-else statement. So that's, we're looking at our vocabulary. An if-else statement is to check and see if some expression is true. And if it is, do something, otherwise do something else. So it's defining a statement that evaluates true or false. So we're going to go through and create a program using the selection and a random plug. And then there's also the idea of the conditional statement, a rule that will run when certain conditions are met, such as a true or false statement. So we're looking for these true or false statements. Anything you'd like to add, Beth, with about selection and random?
No, just that the unplugged versions of these are really fun to do in the car or when you're just in between, at the end of a day, because students love to come up with their own if-else statements just in life. If it's raining, I don't wear my shoes. And they just, especially the younger kids, you can do this with the younger kids and they just think it's so much fun. But it's one of those things you can ingrain in sort of your everyday language. If I put the toast in the toaster and I don't, there's an and in there as well, and I don't set the timer, it might burn. Or else, if I don't put it in the toaster and set the timer, or if I do set the timer, might not have black toast. So that's called a conditional statement. And I feel like a lot of students, that's part of their everyday life. And so we're just trying to make it seem more clear cut with how you would tell a computer about that, how you would direct a robot to do it for you, and breaking it down to the smallest, most minute statement. To be crystal clear about it. So yeah, I think these are really fun. This is a really fun element to teach. If you've never taught about conditionals, don't be scared. Like I said, it's something that happens every day. And with CodeJumper, it makes it a little bit more tangible because of the selection pod that Robin's going to go over right now, and you'll kind of start getting the rhythm of it. And if you don't get it right away, don't worry. Ask us some questions. Keep trying because it's actually very fun. It's a fun element.
So, and for me too, it's easy to tie O&M concepts into the selection pod, and I kind of walk through it thinking about it as traveling down a path, and so we'll go into that. So we're going to go through a couple of these ideas, and so for this lesson, it's really looking at, you have your CodeJumper kit, your computer science journal, and there's two code cards and 2 dice per group. So you can actually, and I'll show you how you can do the dice, which is really fun. All right, so we're going to build this program in thread 1. So if you have a kit, let's first turn thread 1 to Helen's story. So look at the one for Helen's story. And we're going to build this story that is basically like a choose your own adventure. There's multiple endings, multiple options within the story that we can use with the selection pod. So I'm going to change my screen and put CodeJumper back up on the screen. And there we go. And then also I'm going to have the PowerPoint with the thread on there as well. Okay, so in thread 1, first thing I'm going to do is go to the app and change it from Make New Friends to Helen's Story. All right, there's Helen's Story. Okay, and we need to have for this one actually 6 play pods. So have at the ready 6 play pods, and make sure that your plugs have been taken out of them if you had built them before. So I'm going to go ahead and stick them back in there into my little plug holder. All right. So from our app, from our hub, thread 1, our code card says to put in a play pod. So I've connected the play pod, and I'm going to move this over a bit. Okay, so and it says play. Helen is looking for her friends for 1 times speed. So I'm going to turn the sound dial for it to say Helen is looking for her friends.
Haunted house. She opens the door. Her friends jump out and yell. She sees a ghost, and Helen is looking for her friends.
Okay, I turned it until I heard it say Helen is looking for her friends. I'm going to turn the speed.
Helen is looking for her friends.
It says 1 times speed. All right. Second line of code says play. She thinks they might be in for 1 times speed. So I take a second play pod, attach it to the first play pod, turn it to 1 times speed.
She sees a ghost and screams.
All right, and we need to find, she thinks they might be in the.
Helen is looking for her friend. She thinks they might be in the.
Okay, I got it. She thinks they might be in the. All right, third play pod says play haunted house for 1 times speed. Actually, this is a great one for right now. It's almost Halloween, so that's kind of fun. All right, third play pod says haunted house. So I'm going to turn the sound dial for haunted house.
Her friends jump out and yell. She sees a ghost and scream. Helen is looking for her friends. She thinks they might be in the cupboard.
Nope.
Haunted house.
Haunted house. All right, great. And I'm going to turn it to 1 times speed with the duration dial.
Haunted house.
All right, perfect. Okay, and now we need 1 more play pod. And that says play. She opens the door for 1 times speed. So I have another play pod, and I'm going to, and it's already on. She opens the door. Great.
She opens the door.
Perfect. Okay, so we have our lead up to a story, because every good story has to have an introduction. So we have our introduction. We know where she's going. The suspense is killing us. What is going to happen? So now we have to add in, says if random greater than 4. Okay, so what does that mean? How do we do if random greater than 4? So that's when our selection pod comes into play. So I'm going to plug in the selection pod to the end of our program. So we have 4 play pods, and at the 4th play pod, I'm going to plug it in. Okay, so now we have come to this crossroads. So this is like, I like to think of it as if you're walking down the path with our first 4 play pods, now you come to that fork in the road. What do I do? Okay, so we have the 2 dials, and we're not going to do anything with them yet, because we actually look at what we need to have on our actually, we are going to do our dials. We're going to do our dials first. So if in the app, it says the green block coding, and it says if 8 is greater than 4. And so I'm going to actually turn that, because it's telling us if, we'll put random in. So we're actually not worrying about random quite yet. Greater than 4. So on the 3 spoke dial, turn that till it says 4.
2.
Nope, went the wrong direction.
3. 4.
Okay, now let's talk about random. So we turn that dial, it's because right now mine says if 8 is greater than 4, but we want it to be random. So I'm going to go find my random plug out of my holder. And so if you remember, the random plug has a raised print lowercase r on that. And this one I'm actually going to insert into the 2-spoke dial on my selection pod. Okay, I heard it click. So it says if random is greater than 4. Okay, great. So below that on the app, we have, it says else and it says else and then end if. So on the selection pod, we have these 2 ports. So in there, we add our last 2 play pods. And it doesn't matter which play pod we put in where, because we'll change the information on there. So I plug it into the selection pod. So now this is where that fork in the road is. So if you're looking at this tactily, so we have 1, 2, 3, 4 play pods. And then we travel to the selection pod. And when we go to the next one, we have the opportunity to go 2 different ways. We can go to one play pod or the second play pod. So what we're going to do is we need to set these 2 play pods to be the correct part of the story. So if we look at the play pod that's attached to the dial closest to the 3-spoke dial, what we're going to do is turn this one, because it says on our code card, play, her friends jump out and yell, surprise. And then it says else, play, she sees a ghost and screams. So I'm going to turn.
She opens the door. Her friends jump out and yell, surprise! She sees a ghost and screams.
All right. So then for the 2-spoke dial, the one with the random plug in it, I'm going to turn that one to say, her friends jump out and yell, surprise.
Her friends jump out and yell, surprise!
Okay. So now we've created this whole program, and I apologize that it's not in a straight line visually because we only have so much real estate for our camera. So I'm going to press play and see what happens. So we know the beginning of the story, but what's going to happen is this random dial could be any number between 1 and 8, because that's the number of constants we have. So if we were to put a plug in the other one, like the 4, it would always have the value 4. But this one is any random value between 1 and 8. So I'm going to trace the code as I play.
Helen is looking for her friends. She thinks they might be in the haunted house. She opens the door. Her friends jump out and yell, surprise!
Okay, so we played that, and it actually went to the, her friends jump out and yell, surprise. So looking at our statement, it says, if random, some number is greater than 4, play, her friends jump out and yell, surprise. And if it's not, if that statement is not true, then it's going to play, she sees a ghost and screams. So looking at this one, we know that the random number is greater than 4. So it's probably a value of 5, 6, 7, or 8. So it played the first one. It played the, her friends jump out and yell, surprise. So if I play this again.
Helen is looking for her friends. She thinks they might be in the haunted house. She opens the door. Her friends jump out and yell, surprise!
Okay, it played the same one, but if I keep going, it's going to play, eventually it's going to play, she sees a ghost and screams. That means that random value is 1, 2, or 3. So there's a lot of opportunities here to, for, looking at probability of what's the probability that, it's going to play the first sound of her friends jump out and yell surprise. What's the probability of the other one? And, and for the sake of time, I'm not going to go through it right now, but you could roll the dice and say you roll one die. So the 2-spoke dial is a number 1 through 6. And then you change the dial, the number to be that, and then you roll a die for the other one, and then you can work on probabilities. So this is a really great way to introduce a whole bunch of different concepts and those ideas of the conditional statements, the if-else statements, because it can be either one. Let's play it just one more time before I move on.
Helen is looking for her friends. She thinks they might be in the haunted house. She opens the door. She sees a ghost and screams.
So that time it went to the other one because the value that the random plug chose was not greater than 4. It was a 1, 2, or 3. So that's really the idea of this selection pod and the random plug in there, which is really fun. So yeah, just like Beth, I think this is one of my favorite parts of this whole thing is the selection. There's so many things you can do with it. All right, so I'm sure everybody's ready to hear Beth do some talking. So we're going to actually switch drivers, and Beth is going to start sharing her screen and is going to walk through what variables. All right, there you are, my friend.
All right, we'll switch over here.
And make sure you click that button to share computer sound. It's little.
Okay. Okay. Robin, can you see my screen?
Yes, I can.
All right. So variables. Let me get on the right slide here. Oops. There we go. So variables. Can you hear me okay?
Yep.
Okay. Turn up the sound. A variable introduces the new idea about what my kids like to say is X marks the spot. Variables are a fun way to connect algebra and algebraic concepts and thinking and a lot of mathematical concepts into computer science. And it's not scary. So even if you haven't done algebra for many years, don't worry. It's pretty basic, and we're going to walk you through what it is right now. So a variable is really just a placeholder. So when we talk about the pirate story and X marks the spot, X marks a treasure, right? It could be anything. It could be a bucket of gold. It could be a bunch of DVD players. It could be an Xbox. It could be some Skittles or snacks. X could be anything. And that's an important concept that kids are starting to learn mathematically. This is just a different angle talking about it with computer science. So the way that we deal with variables and CodeJumper is through a plug that is a large gray plug with an end on it, much like all the other plugs. But on the top is a hole, and it's sort of ridged like a castle almost. Wouldn't you say, Robin? Like the top of it has longer.
Oh, yeah.
There's like a rim around the top that sort of breaks up at points, but it's not the same as the ridged dial for the sound dial. And so so if you would right now, see, you should have 3 of these in your kit. And I'm going to do a demonstration. You can follow along with me with 3 play pods and 3 variable plugs and 1 constant plug. And I picked the constant plug of 5, and I'll explain why in just a minute. Let me just grab the app here and make sure I'm connected. So I am going to plug in there we go. Could you hear it?
Yeah, I heard that.
Awesome. Good. Okay, so I am going to plug into my hub play pod. And I'm going to make a string of play pods. I'm going to put 3 of them in a row, and it doesn't matter what thread you choose. So in my app, I have 3 play pods connected, and I'm going to choose people sounds because I love the laughing sound.
Oh,
it's one of my favorites. I just think we need to have more laughter these days. Mm-hmm. So this is typical to what we've done before. In the app, there are 3 lines of code. I'm not even going to adjust them at this point. But the first one says play laughing for 1.5 times speed. The second line says play cheer. And the third line says play cheer for different, one of them is 1.5 and one of them is just 1 times speed. Doesn't matter. It's kind of random what shows up. So I'm going to plug the variable plug, the big gray plug, into the play pod of the very first play pod. Okay. And what happens on the app that's a little bit different than, and this is where reading the code out loud is sometimes helpful, is it says on the first line of code where that play pod was, where it did say laughing sounds, now it says play X for 1 times speed. So there's our X marks the spot. It would be a mystery if you were just looking at this and you didn't have all the sounds memorized. It would be a mystery as to what is underneath that X. So the variable plug is pulling a sound. Now, if I click play right now, you heard 3 sounds. The 2 cheers were different because they different tones because they had different speed levels. But that first sound was a little bit different. And we still don't know what it is if you're just reading the app because it says X. So I want to make sure I get the laughing sound. So I have already gone through and decided I want sound number 5. So I'm going to put the purple constant plug that has a raised number 5 on the top of it. I'm going to plug that into the top of that variable plug. So now I have 3 things. I have a play pod with a variable plug and a constant 5 plugged into the variable plug. It's kind of like an ice cream cone almost. There's 3 things flowing together there. The app changed when I did that. Now the app says this under thread number 2. It says X equals 5. It's giving us that information on that first line of code. And then within the same block on the next line, it says play X for 1.5 times speed. Then the play cheer and then play cheer again for the other 2 play pods. So when we're talking about variables with coding, they can come from different elements of code or different places in the code. And sometimes we use variables, we give the name to something, and it basically just has another name. This is just one way to introduce it for students so they start understanding this concept. In this case, we have defined X at the very beginning because I put the constant plug in there. So it says X equals 5. And then as you read the code further along, anywhere else that we put a variable, it is going to put, can you guess? It's going to put an X. So I'm going to actually put another gray variable plug. I'm going to put it into the sound dial of the second play pod. And I'm going to put the third variable plug into the third play pod, into the sound dial of the third play pod. So every play pod now has a gray variable plug. The first play pod has a constant 5. The app changed significantly now, the other 2 lines of code where we put those variable plugs. It says at the beginning, X equals 5, but then the 3 lines of code are a little bit different than what it was before. The 3 lines of code now all say play X for a certain time speed, whatever the time speed was for that play pod. All of them say play X. None of them give us the clue as to what's inside that sound. It's all that mystery treasure box. X marks the spot. But in this scenario, I have decided and said ahead of time with my constant, because I put the constant in the first one in the line of code, that variable gets called 2 more times. A computer uses that when in computer science, you would say it calls the variable or it pulls the variable back from what it was right before it. So in this scenario, in this thread of code, the 5 is defined as the variable, and then it's going to be pulled or called in the second play pod and the third play pod, or the second line of code and the third line of code. It's both pulling that same X variable. So watch what happens when I hit play. It was the laughing sound, the laughing sound, the laughing sound, 3 times in a row. The only difference was speed. Now, speed is something that's set just to that play pod. So you can still adjust the speed, or the it kind of changes the tone a little bit. But yeah, so anywhere else in your program, if you had a more complicated program, if you had a lot more going on after those 3 play pods, you could still pull from the specific constant that you wanted to. This is great because for students to figure out too, because there's only one constant 5 plug. And let's say maybe later in your program, you wanted to also pull constant 5 again. You would have 2 more options. You could pull it with these gray variable plugs, and it would pull the constant anywhere after you have already defined what X is. So that is a concept that, if you are not familiar with computer science, might be a little complicated, and you might need to play with it a little bit. And that's
You have a
exactly
hand raised.
Sorry.
Susie, can you ask your question? Oh, maybe she didn't have a question, just had her hand still raised.
Alerts, your internet
Oh, there you go.
connection unstable. Handling.
Can you hear me now?
Yes.
Is a variable a new idea? Is that right?
A variable is a concept in computer science. It's not new to computer science. No, it's something that we haven't covered in this series yet, if that's what you mean.
Yes, but a variable is a concept that's used in computer science, like programming, like when you did the laughter. The variable, you wanted the variable to be the laughter, didn't you?
Yes.
Okay,
So,
thank you.
yeah, and that is a concept that computer programmers use all the time. And sometimes in coding, and when kids get into text-based coding, they'll actually define a variable as sometimes many lines of code. Sometimes it'll be a whole series or a whole, in this example, like a whole story or a whole song. And they'll call that whole song, they'll give it X, or they'll call it B, or they'll give it a letter or a name. And because they've defined it as that, and they've given it the name of the variable, they can pull as many variables as they want, and then they don't have to rewrite all of that code. So in Robin's example, she did the story of, was it Helen, or the haunted house story? Mm-hmm. And if in, not so much in CodeJumper, but this concept applies to other, as kids move on in their coding, they might say Helen's story as the variable. And if they define it, then they can play Helen's story anywhere else in the code that they wanted to, but they wouldn't have to rewrite all of that code. It's like a shortcut. So this is very introductory because we're not doing an enormous amount of shortcutting, but it is the same concept that kids could pull information from somewhere else without having to have another purple variable or a constant 5. They can pull the 5 in a different way by using the plugs.
You have one more question.
Sure.
Rose?
Sorry, go ahead.
Hi.
Hi.
Not that it would necessarily be something you would do, but just for sake of my understanding, do all of these plugs work in the speed dials as well?
No, the speed dial is separate. The constants and the variables pull from the specific type of sound. So in the sound set, which I'm going to get to next, and I'll show you the sound sets and you can kind of have a better understanding of how they're put together. The constant pulls the different sounds from the sound set. So in this case, it pulled sound number 5. But it doesn't have to do with the speed or the duration of the sound. That is separate. And these I don't believe you can put a constant in, Robin, for the speed or duration. Right.
Thank you.
Yeah, great question.
Yeah, that's a good question. Awesome.
All right, so I think that was kind of it. This is a big concept. And so if you're new to computer science, again, feel free to pop off and ask us some more questions. But I'm going to move forward to making custom sound sets because I know a lot of you want to know how to do that. I know Paul wants there to be sports sounds, but I may not be able to oblige today, Paul, but we'll see.
You have a strange screen appearing for us.
Sorry.
There you go.
Got it. It's not going to let me get bigger. Okay, here we go. So for custom sounds, this is really fun for students. Some of this is something you as an educator could do ahead of time, or it's something you could do with the students, and older students can probably very easily do it on their own. I'm going to show you how to add a custom sound set. When you select the thread that you're on, it doesn't matter what thread you're on. Oops, sorry, my bad. When you go up to the top of I misdirected you, I apologize. When you go up to the very top of the app, there's a bar up there that has some menu choices: Bluetooth, sounds, about, play, read, and stop. If you click on the sounds button, it will open a menu called Manage Custom Sounds. And this is where you would choose to add in any sounds you have already created with your students. The creation part needs to happen on your computer or some other way. It can be a WAV file that you've created with any other kind of recording device. CodeJumper doesn't do the recording for you of your own sounds. So if you wanted to make your own story and have students with their own voice speaking different parts of like the Helen story or the haunted house, you would need to record that using your computer and then create a .wav file ahead of time.
MP3 now too. Yeah, MP3 too.
Or an MP3, yes, sorry. This part I'm gonna walk you through is what happens, what you do with the file and how it's organized. So the recording part happens beforehand. So the custom sound set has a drop-down menu, and right now it's on trains because that's what I have added. But if I click add sound set, you can add and delete different sound sets there, but it opens up a new menu option and asks you to enter the sound set name. So just for Paul, just to be confusing, I'm going to call this Sports Sounds. That's the name of my sound set. Within every sound set, there are 8 options for sounds. So I'm going to click done because now I have named my sound set. I haven't added anything. There are no sounds in there yet. I've just given it a name. So now at the top where it said custom sounds, it did say trains before, and this is a drop-down menu because I have done this before and I have a sound set called trains. It popped up on my menu. Yours might not have anything if you've never made a custom sound set before. So now that it says in the custom sound set, it says I'm in sports sounds. Underneath there, it says sounds in this sound set, and there's another drop-down menu. If I select that, it says sound 1, no sound is added. Sound 2, no sound is added. Sound 3, no sound is added, all the way down to sound 8. And I haven't added any sounds yet, which makes sense because, which is reflective. If I select sound 1, I can go in and add the MP3 or the WAV file, and I will name it sound 1, and I can give it its own name. So I'm going to click add, and I'm going to decide what the name of that is going to be. So let's say I'm going to call it basketball. Then I'm going to select add sound file, and it's going to pull up from my from my desktop. It's going to pull up my file menu, and I'll just choose the basketball sound file and then click done. So right here, it automatically drops me down to sound 2. But if I clicked on that down arrow where it said sounds in this sound set, I can see that sound 1 is now titled basketball. Sound 2 says no sound is added. Sound 3 all the way to 8 says no sound is added. This lets me know that I can add more. I can add up to 8 sounds in this sound set. I can go back and listen to them right here, or I can delete them and reorder them. Sometimes when you're working with stories and students, you really want to think about the order that you are putting them in. If you want it to be that students have to figure it out, you may not want the story to be ordered 1, 2, 3, 4, 5 from the beginning to the end of the story. You might want it to be a little bit discombobulated. So that just depends on what you want. If students just enter things 1, 2, 3, 4, 5, it'll be very easy when they try and play with it with constants. Sometimes that's helpful. So it just depends on your students and what you're trying to do. Yeah, that's kind of it. You can go through and delete and rearrange, but that's all that it takes is just a file and entering them in and giving them each a name. I know teachers who've done this with sound sets. They might have a group name for their students, or they might have a sound set with that student's name as the title, and then each sound is the different, sound, or if it's a poem or a line of a poem, they might name it something generic. But these are when you go back to your thread, when you're at the top, or sorry, when there's no variables in here, in the line of code for everything, it tells you the name of that sound. So where I put basketball, that is where that will come up, and we'll see the basketball sound. I think that's it. To find it, to find your sound set, you would go, when you're ready to play with it, and it's already all entered, you would go into the top of the thread and select the sound category, and you would choose custom sounds, because this is something you created, it's custom. Choose the custom sound set, and then it will give you the drop down. See right there, it says sound set, sports sounds, and I would select okay. And then all of my options, and of course I only entered one, but they would be there that I could play. So I think that's it for custom sounds. This is a really creative way that students might be excited and engaged in coding. This is just an open-ended sandbox here. It's not super complicated, but it is an important part that sometimes keeps kids coming back and coming back and coming back, because they want to create on their own. So if you can, once you get through some of these base lessons, even some of the primary lessons, letting kids have that option to create their own custom sounds from the beginning really gives them that level of ownership. And they love hearing their own voices. Sometimes adults don't love hearing their own voices, but students love hearing each other and being able to tell their story, their song, their poem, or just whatever they happen to be creating. So let's head back to the PowerPoint. So I skipped ahead and I didn't go back to the PowerPoint, but I think we covered all of those things. The slide just shows what I just demonstrated. Yeah. Computer Science Week.
Yes.
Robin, coming up in another, let's see, 6 or 8 weeks. 6
Right.
weeks.
So Computer Science Week is the week of December the 7th through the 13th. The point of this time period is because that is Grace Hopper's birthday is during that time. So there is the Hour of Code, and we have a website, www.hourofcode.org, which is a fantastic place to go get resources and learn about Computer Science Week and an Hour of Code. So it's basically giving the kids the opportunity to code for at least an hour during this time. So many different activities, but also look for Code Jumper materials that are coming soon to do with your students during the Hour of Code and the Computer Science Week. So more will come out on that as it comes available, but keep your eye out for new fun and exciting activities to do with your students during the Computer Science Week. Again, December 7th through 13th, which is pretty great. Beth, can you pop your settings down for Zoom?
Yep, sorry, it just popped on there.
No worries. Okay, so if you can go to the next slide, I think just in the, because of time, again, the same resources that we showed last time, codejumper.com, and then education.microsoft.com is a great hour-long course for CodeJumper. And if you go to one more slide forward, there again these resources, which I will put into the chat. Again, for different coding resources, code.org, like I just talked about, Hour of Code, k12.cs.org, computerscienceteachers.org, and CS for All. So I'll just throw these into our chat, and so everybody can access these. And I think, oh, did it get all of them? Oh, it did. Okay, so yeah, we just put it on. Leanne and I did. You guys are gonna get double all of those resources, all the time for days and days. So thank you so much for coming today. Let us know if you have questions. You can find Beth and I on Twitter. And yeah, so keep on code jumping.
Thank you so much, Robin and Beth. That was fabulous. And I am going to say we have more coming up. So stay tuned.